Firebase storage is now officially supported by AngularFire2, which means uploading files from an Angular application is easier than ever before. In this episode, I'm going to take you through the new features in the AngularFire2 storage module. Then we'll use it to build a Dropzone file uploader from scratch. In addition to uploading files to Firebase storage, it can also control the entire upload process by pausing, canceling, or resuming an upload. There's a whole bunch of other cool stuff I want to show you, but first make sure to like and subscribe and grab the source code from AngularFirebase.com. Before we jump into the code, I want to give you a few more details about how the AngularFire2 storage module works. When we drag and drop a file, it's going to start an AngularFire upload task, which will immediately start uploading the file to your Firebase storage bucket. You can then monitor the upload progress as an observable. The snapshot is emitted several times per second, so you can do things like update your progress bar or just provide the user with some helpful feedback. When the process is complete, it will give you back the download URL that you can show in your front-end UI. Now let's go ahead and build this thing. We'll start with a brand new Angular 5 app, and then inside that project, install AngularFire2 and Firebase. Then inside of your Angular environment, add your Firebase project config. And lastly, we'll go into the app module and initialize our AngularFire app. I'm bringing in both the AngularFire storage module and the Firestore database for some advanced stuff I'll show you towards the end of the video. Now that we have AngularFire2 set up, we need a way to retrieve a file from the user's device into our Angular app. We want the user to drag and drop a file, which is a perfect use case for an Angular directive. We want to use this directive on an HTML element and have it emit custom events based on certain drag and drop activity. We can create custom events in Angular by using a combination of host listener, output, and event emitter. The first thing we do is create our custom events, which we do with the output decorator. The first event is called dropped, and it is fired when the user drops their files onto the drop zone. The event's going to emit a file list, which contains the actual files or file that we want to upload to Firebase. I'm setting up a second event here called hovered just to emit a boolean based on whether or not the user's hovering over the element so we can toggle some CSS classes. From there we can use host listener to listen to the drop event from the browser. And the first thing we want to do is prevent the default behavior because otherwise the browser is going to want to open up a new tab. The event's going to contain a file list which we can extract by calling event data transfer files. And we'll emit that through our dropped event emitter. We'll also set the hovered event to false. That's the most important part, but we also want to listen to the drag over event, and we'll set our custom hovered event to true when that occurs. Then we can emit false on the drag leave event. And we'll also want to prevent default on these events as well. That gives us a bare minimum drop zone. Now let's put it to use in a file upload component. The goal here is to give you a pretty extensive tour of the new functionality in the storage module. The first thing we'll do is import AngularFire storage and the AngularFire upload task. From there, we're going to declare a few variables. The main part of AngularFire storage is the task. It's the object that gives us access to the observable data and allows us to pause, cancel, or resume an upload. One of the observables that it gives us is the percentage changes, which is really useful if you're doing something like showing a progress bar. But you can get even more data than that by observing the actual snapshot. When the upload's complete, you're probably going to want the download URL, which you can also listen to as an observable. The last thing I'm doing is setting up a Boolean variable so we can toggle some CSS classes. The next step is to inject AngularFire storage into the constructor. Then what I really want to focus on is this start upload method, which will kick off the entire upload process. This method is an event handler, and it will take a file list as an argument, which we'll get from our directive that we defined earlier. So when the dropped event fires, it's going to start the upload. We can get the first file from the list by calling event item 0. A file list is kind of like an array, so you could iterate over it if you plan on uploading multiple files at once. The next thing you might want to do is provide some client-side validation. So in this case, we only want the user to be able to upload image files. We can look at the MIME type on the file that was selected, and if it's not an image, we'll just go ahead and console error and return from this function. And because we want full stack security, we're going to mirror this logic in our backend Firebase storage rules. To do that, we look at the incoming request and make sure that the content type matches image. Now that we've secured our upload, we need to tell Firebase where to actually save it. Storage doesn't generate a unique ID like the Firestore database does, so it's generally a good idea to give your file path some sort of unique identifier so it doesn't get overwritten by a file of the same name. The easiest method is just to use a JavaScript date with getTime and append it to the file name. That's going to make file name collisions extremely unlikely. You can also save your own custom metadata on the image itself. There's probably a ton of different use cases, but for now I'm just going to pretend that I have multiple apps and I want to know which app actually uploaded this image. Let's say it was uploaded from my AngularFire powered progressive web app. At this point we have everything we need to define the actual upload task. To do that we call storage upload and we pass it the file path as well as the file itself and an object of our custom metadata. And the metadata is completely optional, by the way. When we call upload, it's going to immediately start the upload process. There's no need to call subscribe on it like you would with an observable. It works by giving us observables that we can listen to monitor the actual upload progress. We get the observables by calling percentage changes and snapshot changes. And the last thing we'll do is set a download URL, which is an observable that emits once the upload process is complete. Now, one final thing I'm going to do is determine if an upload is active so we can toggle between the paused and resume states. Every snapshot that gets emitted has a state, which might be running or paused, and we can also look at the bytes transferred and compare them to the total bytes in the file. The data contained in the snapshot can be very useful for customizing the behavior of your front-end UI. Now let's jump over to the component CSS file. I'm not really going to talk about the CSS, but I do want to give you one helpful tip. The snapshot emits data in chunks, so you can smooth out the transition on your progress bar by just adding a simple CSS animation. In this case, a transition animation on the width was hugely helpful at smoothing out the progress bar. Now let's jump over to the HTML and put everything together. First, we'll set up a div and add our custom Dropzone directive to it. That will give us access to our hovered event to toggle the CSS class, and also to our dropped event to know when the files were dropped in this div. That emits a file list, which will pass on to our start upload method to immediately start the upload process. In addition to drag and drop, we also want to give it just a plain file upload button. This is especially important on mobile devices because it will bring up the user's camera, which will allow them to either take a picture or select an existing picture on their device. All we need is an HTML input with the type of file, and then we'll bind it to the change event and fire off the same start upload method. That's all it takes to build a drop zone, but we also want to show a progress bar. To do that, we're going to use the percentage observable that we set in the component type script. We can unwrap it with the async pipe and then set it as a template variable called %. It emits a number ranging from 0 to 100, and we can use it as the value in our progress bar. That's really handy, but we can also take this a step further and unwrap the snapshot in the HTML as well. The snapshot contains information about the bytes transferred and the total bytes in the file. That's not very user-friendly by itself, but what I did is create a file size pipe that will round it to the nearest format, such as megabytes, kilobytes, etc. The pipe was really easy to create because I borrowed all the source code from the Wrangle.io Angular training book on custom pipes, and I recommend you do the same. The next thing we can do is unwrap the download URL. We can give the user a URL to download the file directly, but since we're dealing with images here, we can also set that URL as the source of an HTML image. Now, the only thing left to do is set up a few buttons here so the user can toggle between pause, cancel, and resume on the upload task. Doing that is incredibly simple. All we have to do is set up a button and bind the task pause method to the click event. Then we only want the user to be able to fire this if the upload is actually active at the time, so we can use that isActive helper that we already defined and pass it the snapshot. We also have a cancel method on the task, which we can set up in the exact same way. Then if the download is paused, we want to give the user a way to resume it. So to do that, we call task resume. And this button should be disabled unless the snapshot state equals paused. And just like that, you now have your own AngularFire drop zone. But we're not quite done yet because I did promise you one more advanced thing with Firestore. There's a good chance you'll want to access your file later on, so we can save information about that file in the Firestore database. We can do this with just a few lines of code. First we'll bring in Firestore and the tap operator from RxJS. Then we'll inject Angular Firestore in the constructor. Because we already have an observable of the snapshot changes for the upload, we can pipe in the tap operator to make a call to our database once the upload is complete. What we want to do here is make sure that we only fire this on the last snapshot, which is going to happen when the bytes transferred equal the total bytes of the file. Then we can simply make a reference to our Firestore collections, which I'll call photos, and then we'll add some data about this file. The only important piece of data to save here is the file path, because you can retrieve that from your database and then make a call to storage using the getDownloadURL method to retrieve the actual file. Now let's jump over to the Firebase console and make sure everything works. First, we'll look in our storage bucket just to make sure our images are being uploaded along with their associated metadata. And you can see the metadata down here at the bottom. Then if we jump over to the Firestore database console, we should see this photos collection along with the file path to that actual storage location. In other words, you have successfully connected your persistent app data with your stored files. I'm going to wrap things up there. If this video helped you, please like and subscribe, and you can look forward to a whole bunch more videos in the near future involving AngularFire storage. Thanks for watching, and I'll see you soon.